All right, can everybody see the problem?
Yes.
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 Okay, so remember, it's always going to be our desired dose or our, doctor's order over what we have. So in this particular case, what we have is 200 milligrams IM of this kanamycin. All right, remember it's a myosin, so I always do my farm teaching when I'm seeing a math problem. I can't help it, okay? So myosins, they never let you win, right? Those are broad spectrum drugs, meaning that these are those hard toxic drugs they go to when other things aren't working. So myosins never let you win. They affect your kidneys and your hearing. So they'll make you toxic. Your kidneys nephrotoxic, your hearing autotoxic. Those are those myosins. They're horrible on the body. All right, so we have this myosin 200 milligrams. We have an IM dose available. And you'll be doing this. You'll be given something like Rocephin. And what'll happen is it'll come in a little bottle in a white powder, and they'll give you another little bottle of sterile water, and usually, and you'll mix it together, and then you'll draw up your dose to give it to somebody IM. Rocephin is a big one that we reconstitute all the time because it's given a lot for cellulitis and things along that nature. And sometimes in an IV bag, you'll have to reconstitute a fluid. You'll get a bag, it'll be on top of the IV bag. I think it's Tigor. And when you get the bag, you got to break that bottle on the top of the bag, and then you squeeze the solution into it, and then you put it back upside down and let it drip back in there, and then give an IV. So we have this 200 milligram dose available that we want to give IM. Now we're going to add 2.3 mLs of sterile water. That doesn't matter. That's just the manufacturer's instruction. This is how they want you to mix it. So just like when you go in the kitchen and you get a canister of instant iced tea, right? And let's say sometimes you're going to make a pitcher, but sometimes you just want a glass, right? So you're going to take one scoop and put it in a glass, and you'll add water to it. And that's all you're doing here. You're just adding water to it. They already determined what the concentration is going to be, or what the concentration should be when they send it to you from the pharmacy. What you just have to remember with reconstitution is that sometimes they have it set up so that you can reconstitute for a couple of different doses. So you always want to make sure that you read the label and that you read the manufacturer's dose. All right. All right. So we're making 200 milligrams. We're adding this 2.3 mLs of sterile water. And what we're going to ultimately end up with is 1 gram per 3 mLs. So let's find our whiteboard. So we have 200 milligrams. That's our order. All right, IM. That's our desired dose, our doctor's order, whatever you want to call it. What we have on hand is 1 gram per 3 mLs. So now you got to convert, okay? It doesn't really matter which way you go, but I would convert to what I have on hand most of the time, just because I really can't alter what I have on hand unless I go to the pharmacy. Sometimes that's possible, sometimes it's not, okay? So in order to go from grams to milligrams, okay, for those of you that struggle with this, I'm just going to show it to you. Okay, we have grams here. milligrams, micrograms. Okay, so if we're going this way, from grams to milligrams, we're going to multiply. And if we're going this way from milligrams, from micrograms or milligrams to grams, then we're going to divide. Or you can do the zeros. All right, so if I took the 1 and I multiplied it times 1,000, it would give me 1,000 milligrams per 3 mLs. My doctor's order is 200 milligrams, right? So the milligrams is going to cross out. My 200 divided by 1,000 is what?
0.2.
Just 0.2?
0.2.
And then times it by 3, yeah.
And what'd you get?
0.6.
0.6.
Okay, so 0.6 mLs is what you're going to give. Anybody not understand that?
So I understand this, but when you go back to the problem and it's 2.3, that's just, is that always going to be like irrelevant for reconstitution?
It is irrelevant because it's not how much you dilute it with, it's what you end up with.
Okay.
So do you remember back in PN school when you guys went through fluid and electrolytes and you would measure like what the concentration of the fluid was? So like you would be looking at how much fluid is in a particular item. And okay, can you see it?
Yeah.
Okay, so we have, now see if you guys can do this. We have Welchorvin, 1 milligram IM. Okay, comes in a vial containing 50 milligrams. So directions for reconstitution are add 5 mLs for a final concentration of 10 milligrams per 1 ml. So our order is what? Don't be shy.
1 milligram.
1 milligram.
I am.
1 milligram.
Okay, so that's our desired dose. We know that goes on the top, right?
Mhm.
Okay, what is our final concentration?
10
milligrams
milligrams per 1 ml.
Per 1.
Okay, so that's what we have on hand. Now it's saying how many mLs would you draw up, rounded to the nearest tenth?
For 0.1.
0.1.
0.1.
Okay, is that what everybody got?
0.1.
Yeah.
Okay,
It kind of gets you when they add all like the extra, you know?
All the extra.
Yeah.
Yeah.
it does. How about these? Everybody good with these? You're gonna see some of these.
I think
So
so.
is that the answer?
Is what the answer?
The 0.1?
Yeah, that was the answer. Everybody
Okay.
got that, right? I didn't do the math, but I trust you guys.
Oh boy. Miss Sue.
I shouldn't trust you.
We
Okay, okay,
Maybe not yet.
okay, let's do the math.
Maybe not yet.
Yes. I'm like, oh no. You can't trust
Graduate.
me. I know that.
Kelly.
Oh, sorry. She knows it too. Miss Sue knows it too. Especially with math.
Okay, our order was what? 1 milligram?
1 milligram.
Mhm.
And we had 10 milligrams.
Mhm.
per 1 ml.
for 1 ml. Where's my I don't even know where my calculator is. Oh, here it is. See, I got that boy here. He jacks my phone. Jacks my electronics. Doggone kids. They just be thinking if it's yours, it's
Thank
theirs.
you.
Okay, so we got 1 divided by 10 times 1, and I got 0.1. Is that what you guys got?
Yes.
Yeah.
Yes.
Okay, see,
Confirmation.
you know how to do it. Y'all know how to do it. You just get yourself all flustered when you get to the exam.
Yes,
Yes.
me too.
Very true.
And it doesn't have to be like that. You just got to feel confident. You're not going to have one of those on there. So I'm going to go to one that you're going to have on there. All right. You're going to have one like this, but the only difference is it'll probably be a lot more hours.
We don't
Okay.
see it. We don't see it, Ms. L.
You don't see it?
No.
Mm-mm.
Can you see it now?
Mhm.
Yes.
Okay. So who's going to do it?
So 1,000 milliliters is our volume
Right.
divided by our time in minutes. So it'd be 10 hours times 60, I think,
So that should be about 600 minutes.
600
Mhm.
minutes. So 1,000 divided by 600 times 20.
You did 33.
Where'd it go?
Yeah, I
Well,
got
not like
33
this.
as well.
What Caitlin said, 33.
I was gonna say like it's 33.333, but then
Yeah.
yeah.
But then I think you need to have
Then you
a
put
whole number when
Yeah.
it comes to.
So when you're talking about a drop factor, yes, because you can't give
can't
a
give half a
partial
drop.
drop. Yes.
Yeah.
So I'm just double checking your math. 1,000 divided
Okay.
by 600 times 20, and I got 33.3. So it's going to be 33 drops.
Your browser's on.
Okay. So we're going to do a problem like this, and then we're going to do a problem similar to this in another fashion. So first, let's do this problem. So how many capsules are you going to give the patient?
Is it 2?
I got to do the math. I could just look it up, but oh, come on, phone. Yeah, it should be 2. Okay, now we're going to do a similar. Did anybody not get 2? If you're struggling, speak up now. You're not the only one that ever struggled in math. We're gonna see if the math works out because I'm just picking numbers, so. Okay, so let's say our dose is for 0.5 grams and we have 250 milligrams per 5 mLs on hand. So I want you to calculate how many mLs you're going to give and then how many teaspoons you're going to give.
So are we given the 10 mLs?
And it's is it 2
Okay.
teaspoons?
2 mLs and 2 teaspoons.
Correct, 10 mLs and 2 teaspoons. Is everybody good with that?
Yes.
Yes.
That's
Yeah.
yeah.
Am I coming?
Okay, so you have a medication set at a rate of 70 mLs per hour at 9:05. There's a volume of 200 mLs. So you're going to calculate the infusion time and the completion time. So for infusion time, what do we need?
mLs per hour.
Okay. So it's going mLs per hour and you have a total volume of 200. So if you do what? How are you going to get that answer? What are you going to do here? What kind of math?
200 divided by 70.
Okay.
Get 2.857, 2.86,
9. 2.9.
2.9, yeah.
Okay. Now how about stop time? 2.9 hours.
Mhm.
So you have to add 2.9 hours onto 9:05. And how do you calculate that so that it comes out right so that you get the right answer?
B. Military time.
I would pick A
That's-
just because they gave us 9:05.
But you be guessing?
Huh?
Right.
Would you be guessing?
Would I be guessing what?
Well, won't,
The
If you
Because
time.
picked
in
A,
the-
would you be guessing or you know for a fact that would be the time?
So I feel like. What do you mean? What do you mean? I mean, I'm not guessing. I don't think. I don't get what you're meaning.
the
What I'm
only,
asking,
How do you calculate
I'm
it?
asking you, do you know how you calculate how do you
Mil-
calculate it to get the 11:59?
Oh.
2 hours.
Yeah.
9,
So I
10,
just
11.
yeah.
So what do you do? Go ahead, tell me.
Would you do the 0.9 divided into 60? Or
Yes.
okay.
Well,
So
actually,
I've
I think
heard-
it's 60 times 0.9. I
Yeah.
think it is.
Yeah. I
Wait,
flipped
where did
it.
we get 0.9 from? 60 times.
So you
So-
just got it from the 2.9 hours, right? So you just
Yeah.
because 2s are whole, and then the 0.9 is what's left
Oh,
from
okay.
not being whole, I guess.
69.
So at first I was guessing
Oh.
for sure, if I'm being honest.
Well,
Okay, Ms.
So is
Roche,
it
I have to
A or
ask
is
a
it B?
question though.
Okay,
Um,
so
it-
let me
can-
just explain it to you.
Mhm.
Okay, so it's 9:05 now. Okay,
Mhm.
your infusion is going to stop. You figured that the infusion would stop 2.9 hours from now. So if I add 2 hours to 9:05, that gives me 11:05, right?
Mhm.
Mhm.
But then how do I add 0.9 hours to 05? Because I still have the 05 and I got to add
Oh.
that 0.9 hours to it, right? So I have to
Mhm.
convert that 0.9 into minutes.
Okay.
So I'm going to take that 0.9 and multiply it times 60, and that should give you 54 minutes. So now I have 11:05, and when I add 54 minutes to it, it gives me 11:59.
Got it.
So it's 60.
And that was 0.9 times 60, right?
Correct.
Okay.
Okay, Ms. Roche, the only question I have, because in nursing, we usually use the military time. So, I mean, is this just a trick question? I mean, which one is
It's
it?
not a trick question, and you don't usually use the military time in nursing. Some
Well-
places use military time, not everybody.
40.
You see, that's it. Every place I've worked, we've used military time. I've never worked in a facility where we used regular time. So this is why I'm always tied up with this.
And except when I was in the military, I've never worked anywhere that uses military time as a nurse.
Okay. So the
So
standard is regular time then.
no, it's no standard. It's whatever the facility uses. So a lot of facilities do use military time. But if you're going, it would either say calculated in military time or the first number would be military time. So in other words, if they expect you to end it in military time, it has to start in military time. And 9:05 p.m. is not in military time,
Okay.
because what would that be if it was military time?
2105.
Okay.
Got it. Okay, got it.
Now, if it said 21:05 there and you were calculating, you definitely would want to put military time on the next one. Now, another thing I want to show you guys is that got you questions marked wrong. You notice with the military time here, there's no dots. When you write military time, there's no colon. All right, that's only for standard time, no colon for military.
Mhm.
Because a lot of people miss their question because they
Yeah.
put the colons in there, and if you put that in an exam, it's going to mark it wrong.
I also don't like how they do the multiple choice, because if you go down, they're all out of order. So if you aren't reading and you're just
Mhm.
thinking like, oh, okay,
It's
like
not, that's not supposed to be like that. Okay, here. All right, we have 2,000 mLs. We wanted to infuse in 3 hours.
You wrote 200 mLs.
All right, we wanted to infuse in 3 hours. And after 1 hour, 300 has infused. So after 1 hour, 300 of it is out. So using the 3-hour infusion time, and it's infused for 1 hour, I said. So we want it to go for 3 hours. And it went 1 hour. So it went 1 hour and it burned 300 mLs. Okay. So now I want you to tell me, with a drop rate of 15, okay, what is going to be my drop rate after you do that calculation? All right, so you have 2,000 mLs to start. It was supposed to go for 3 hours. After 1 hour, it stopped, okay? And 300 mLs was out of the bag. So now you're going to restart it with the volume that's left. It's going to go over the remaining time, and your drop factor is 15. Everybody got that?
Yeah.
Yeah.
Mhm.
Yeah.
Okay, so would that be like 212?
I got 213, 212.5.
Okay, well, let's see.
Yeah. 213. Yep.
All right, so we had 2,000 and we lost 300. So that left us with a total volume of 1,700 mLs.
Yes.
Okay. We started with 3 hours, but the bag already went for 1. So that leaves us with 2 hours, which calculates to 120 minutes. And then your drop factor is 15, right? Is that what everybody did?
Yes.
Yes.
And you got 212.5, which rounds up to 213.
Exactly. So that was correct. Okay. You would never give that many drops. And I changed the numbers a little bit because I can't give you the exact numbers and the exact formula, but you have the gist of it. Okay.
Yeah.
So you have to just really read what is the problem asking me. Okay. Mm-hmm. Okay, babe. Okay, here's your order. You got my phone?
So 30.
I didn't get 30. You said 30 as in 30?
I got 3.
Yeah, that's what I got was 3.
Okay, so it's 15,000 divided by the 25 multiplied by the 3, sorry. Yeah.
Okay. So anybody not get 3 on that?
Great.
All right, everybody can read that?
Yes.
So you're calculating drops per minute here.
I got 78.
78.
I got 78.
78.
Okay, let's see. You should have took 550, divided it by 425, and multiplied it times 60. Is that what you did?
Yes.
Yeah.
Yes, that's what I did.
Anybody not understand that?
So the answer is 78, right?
Yeah.
I'm about to do the math now. I got a little side distractor over here that keeps still on my phone. It's a shame because he's here all the time and I'm always on Zoom, so I guess he's trying to get my attention. You know how kids are. Oh, can I do some math tonight? Yeah, 78. I'm just picking random numbers, by the way, but you know, I know my math's good. Okay. The formula, as long as you got the formula, the math's always going to be good. Sometimes why you get your math wrong is because, you know, you should always check it twice. Right? Because sometimes I'll punch a number in wrong. You don't catch a number with your thumb or something, and then you get a bogus answer and it makes your whole answer wrong. Let's see. Okay. Do the math.
So is it 2?
I'm doing it now.
Yeah, I got 2.
So yeah, it's 2. Anybody not get that? And when you see these and thus it tells you to add for additional doses, you're only doing for 1 dose. Unless it tells you otherwise.
I made that mistake a couple times.
In the beginning, I should have did.
Yeah, I would use the BID and
Yep.
Okay. How many teaspoons you gonna give?
So that be 4? No. Tablespoon is 10 ml, so 2.
2.
Two.
I got 2.
Yeah, I got 2. Anybody have a problem with this one?
No,
No.
no.
Okay, last one, and this should be all of them. we did at least one or two of each one that you'll see on the dosage calc. All right, so. That didn't look good. Okay, can you see it?
Yeah.
Yes, I got 2.7.
Okay, how'd you get 2.7?
What's wrong? I divided 10,000 by 15,000 and multiply by by 4 ml. I don't know.
Okay, so the 4 mLs is fluff. That's why I put it in there.
I just saw that.
So if anybody else did that, that's why you didn't get the right answer.
All right.
So it's 0.667 then?
Yeah,
Mhm.
0.67 mLs.
6.7. Okay.
Anytime you see
0.6.
multi-dose, that means that they're sending more than one
Wow.
dose from the pharmacy because they only want to make one trip.
Mm.
Okay, so that's why
Okay.
they send the multi-dose files. All right, anybody
How
have
did-
any other?
Yeah, how
sorry.
did we get that answer? Sorry.
What was the number? 0.6?
Yeah, I'm going to show you.
Okay,
Yeah.
0.67, 0.67.
0.67.
So what you had ordered was 10,000 units, right?
Mhm.
Right.
And what'd you have on hand?
15,000.
15,000.
You had 15,000 per 1 ml.
Mm.
Yeah.
So when you divide that and multiply it times 1, you get 0.666, whatever.
6.7.
And then it goes up to 0.67,
Yep. Okay.
which actually in the real world, depending on what you're giving, you probably would just give 0.7 mLs. Because if it's an injection, you're not going to be able to give 0.66 or 0.67 or whatever. You know, if it's a kid medicine, then you're going to have to talk to the doc or figure out if you can do it safe. because you wouldn't want to get that much over every time or under. That's all you want to make sure of. Normally, I wouldn't use this calculation, but I didn't want to use the calculation that's on the dosage exam because when you guys ace it, I don't want anybody saying you had an unfair advantage. All right.
Yes, ma'am.
Yes.
Thank you.
All right, guys.
Thank you.
Thank
Thank
you.
you.
Thank you,
Have
Miss
a great
Sue.
Good
night.
night.
Have a
You're
good
welcome.
night.
Good night,
I'll see you
everybody.
Bye. Good night.
Saturday, whoever makes it.
Okay.
I'll
see
ya.
Good night.
All right.
Bye.
Bye-bye.